So in arithmetic sequence, you add or subtract to get the next number. In a geometric, you multiply or divide. So if I have 2, and then I have 1/2, and 1/8, and 1/32, what I'm doing is I'm multiplying by 1/4 to get the next number. So that is called the common ratio. So the common ratio is the second, third, fourth term divided by the previous term. So I can just divide the second term divided by the first term. Just like in the common difference, you do the second term minus the first term. This one you're dividing because the geometric sequence is multiplying. So the explicit formula is a sub n equals the first term times r, which is the common ratio, to the n minus 1 power. And then the recursive formula is a sub 1 equals a sub 1, so that means that's the first term. And then to get the a sub nth term, you have to take the previous term. So remember, to denote the previous term, we do a sub n minus 1 times the common ratio. So the next part, identify whether the sequence is arithmetic, geometric, or neither. So first I'm just going to add and see if, well, if it's going positive, negative, there's no way that can be an arithmetic, so it's not arithmetic. Now to check for geometric, I do this term divided by this term, this term divided by this term, this term divided by this term, and if they're all the same, it's geometric. So this one is geometric, and the common ratio is -6, because when I divide each of these sets, I'm going to get -6. Number 2, I'm just adding 2 every time, so this is an arithmetic sequence, and the common difference is 2. Number 3, I can tell it's not arithmetic right away because it's going back and forth between negative and positive. So I'm going to divide 384 divided by 96, and then I'm going to divide 96 divided by 24. I think it's going to work, but I'm just going to check. So 384 divided by 96. Oops, 384 divided by 96 is -4. So this is -4, this is -4, I know, and this is -4. So yes, it's geometric, and the common ratio is -4. And this one, I'm adding 3, I'm adding 5, I'm adding 7, so it's neither. Even though you're not adding the exact same term every time. So just like there's the arithmetic mean, there is the geometric mean. So the arithmetic mean, I'll go over here. So the arithmetic mean is to add up 2 numbers, two terms in a sequence, and divide by 2. The geometric mean is going to be to multiply 2 numbers, so maybe a sub n times a sub n plus 1 the next term, and take the square root. So in this number 5 is an application of it. So a family purchased a home for $150,000. 2 years later, the home had a value of $188,160. If the value of the home is increasing geometrically, how much was the home worth after 1 year? So you have the first year is $150,000, and then you don't know the 1 year, but you know the second, or the after 2 years, it's $188,160. So essentially what you're trying to do is find the geometric mean. So what you're going to do is you're going to multiply these 2 numbers, and you're going to take the square root. So when I did that on my calculator, I got exactly 168,000. So after the first year, it's worth 168,000. So I'm going to do the same for each of these because you're finding the middle term of these. So I take, this is the square root of 20 times 80. So this is the square root of 1600, which is 40. This next one I can't do in my head so much, so I'm going to do the square, I'm going to do 3 times 18.57, and then I'm going to take this 18.57, and then I'm going to take the square root of that. So this is approximately equal to, because I rounded, 7.5. And then number 8, I'm going to take the square root of 28 times 5103. And I get exactly 378. So arithmetic mean you add them up and divide by 2, and then geometric mean you multiply them and take the square root of it. And then number 9, find the 19th term of the sequence. Okay, 19 is a lot just to keep going on with this sequence. So what I would do is I'd find the explicit formula. So I'm going to write down the explicit formula again. So it's a sub 1 times r to the n minus 1. So we need to find a sub 1 and r. So a sub 1 is pretty easy. I mean, it's because it's the first term. And then r is the second term divided by the first term. So that's a sub n equals 11, because that's my first term, times r, which is 3 to the n minus 1. So what I do when I'm finding the common ratio, I always put it in parentheses. It's not necessary if the number is positive, but if the number is negative, you need to have this in parentheses because you're taking it to an exponent. And if the exponent is even, that's going to make a difference and come out positive versus negative if you didn't have parentheses. So a sub n equals 11. Well, actually, I'm trying to find the 19th term, so I can do this right now. So the 19th term is a sub 19 equals 11 times 3 to the 19 minus 1. So in your calculator, I see people mess up by not putting this in parentheses. So, just make sure that 19 minus 1 is your exponent, or just make sure that you have used 18. So I've seen people put all this in their calculator, and then at the end they put minus 1 that's not being exponentiated, and so that's where you can get a number that's off. So just be careful. So I'm going to do 3 to the 18th power, and then I'm going to multiply it by 11. And that is a huge number, so it's 4,261,625,379. It's huge. That would be huge to write all those terms out for the 19th one. And then number 10. Is this one even... Okay, I'm going to check this. Wait, so at first I was thinking it was geometric just because that's the lesson we're on, but actually this is arithmetic because it's just going down 3 every time. So I'm going to use the general formula of arithmetic sequence, which is a sub 1, or a sub n equals a sub 1 plus the common difference times n minus 1. So a sub n equals a sub 1, which is 20, plus the common difference. I'm going down 3, so it's negative 3 times n minus 1. So to find the 19th term, I'm just going to plug in 19 for n. And then plug it in my calculator, and I get negative 34. Okay, number 11. Suppose you have equipment that can enlarge a photo to 120% of its original size. A photo has a length of 10 centimeters. Find the length of the photo after 5 enlargements. So this 120% represents R. So you're not going to just do R as 120. Remember, 120% is basically to multiply it by 1.2. So you have your R, and you have your... And a percent automatically means geometric. And you have your a sub 1, and this is after 5 turns. So I'm going to write my explicit formula, which is a sub n equals a sub 1, which is 10, times r, which is 1.2, to the n minus 1 power. But I want 5, so I want 5 enlargements. So I do a sub 5 equals 10 times 1.2 to the 5 minus 1. I can put that in my calculator. So again, be careful that you're just going to do 1.2 to the 4th power. So, and I get 20.736 centimeters. Units are centimeters. Okay, I just want to add right here, I did not put that these could be negatives. So when you're finding, let's see, so this would work for number 6, 7, 8. So when you have a geometric sequence and you're trying to find the missing term or the geometric mean, you got to think about that the common ratio could be negative or positive. So actually this number could be negative 40 or positive 40. And this number could be net plus or minus 7.5. And this number could be plus or minus 378. There's not enough information. If you had more numbers right here, if you knew this was positive, then you would know that this one's positive. But if you knew that this one was negative, then this would have to be negative. But when you only have 3 numbers or 2 numbers and you're trying to find the number in between, you have to get the positive and the negative.